Hey guys, welcome back. So in this session, we're going to be looking at longest list mapping in Grasshopper. And this is something that really gets overlooked, and it really shouldn't, because it's a really important concept about how lists are mapped to each other in Grasshopper. And the function of this is acting constantly. It's always prevalent, longest list mapping. Whenever we're plugging two components into each other, whenever we're plugging a wire in, longest list mapping is at play. And by not understanding it, it can be a real problem, because you end up exponentially creating problems in your script by not understanding the behavior. And long list mapping is the default behavior of Grasshopper. We can change it, and I'll show you how to do that. But this is, the default behavior that's constantly going on in the background. So let's switch over to Grasshopper, and we can take a look at this script that I have set up. And we're just going to talk through this, step by step. This is high level theory. Actually, let me just go back. This is high level theory that we're talking about. And generally, I don't do a lot of these videos because I'm really more focused on computational thinking, developing these skills to be able to create anything you can imagine in Grasshopper. And, this theory and foundations are obviously key to that. But, there's so many resources out there about, list and data structures and all of these different kind of core aspects of Grasshopper. You can search them out. There's thousands of videos. It can be overwhelming for sure. So whenever I do these, I like to just focus on the really critical pieces of knowledge that we need to know. So really focus on some foundations. And this is one that is, longest list mapping is one that is just not understood by people. So we're going to fix that today. So back to Rhino. And I just have this super simple script set up. I'm just going to clean it up a little bit just so we can make sense of all this. Sorry, this was for one of my programs that I'm running. And so, yeah, just talking through this, we have two curves, curve 1 and curve 2. These are both referenced into Grasshopper. And we have a divide curve function. So we're dividing each of the curves by a number. That number is defined by the n value of our divide. Very straightforward. And what this is doing is creating two lists for us. We have a list of points coming out of my first curve, or my first curve divide. And I have a list of points that obviously matches exactly the length of my count. And the same for curve 2. I have the orange ones at the bottom and the white ones at the top. And you can see this list changes length depending on what that number is. Straightforward. So now when we're talking about list mapping, we are now going to draw a line between these two sets of points. And so when I talk about list mapping, this is this is what happens. The line tool is picking up both of these lists of points. It's mapping them together, and then it's doing something with this. In this case, it's creating a line. So if we put these two lists next to each other, just to to visually show this, we have our point on our white curve, our curve at the top, and we have our point on our bottom curve, our orange one. And we're simply drawing a line between item 0 and item 0, item 1 and item 1, item 2 and item 2. So these lists get mapped to each other in a very direct way. So this is what we're talking about when we're talking about list mapping. It's the way Grasshopper maps these two structures to each other. And it gets more complicated this with data structures, but what I want you to understand is just this basic level to begin with. So this makes sense. Okay, even this is straightforward. There's 10 points, 10 points. We draw a line between 10 points. Fine. So what if I come back to the beginning and I'm going to change the length? I'm going to change how many points that I have on one of these curves. Actually, sorry, just quickly before I do that, if you don't know what this points list component, I'm just going to add turn the points lists on. And what this does is it's located in display and vector. You have points list. And this takes any list of points and it just adds the index to the screen as a preview. And it's a 3-dimensional piece of text. So it's really, really helpful to see the order of points. The order of things is very, very important in Grasshopper. So this is a very good way of being able to see that. And yeah, you can see we have 0 to 10 on our first curve, 0 to 10 on our second curve. Lines being drawn across, the mapping between the two, etc. When we change the length of one of our list lengths, so I'm going to now reduce the length of this, and I'm going to put, say, 5 points in. So I have 5 points on my bottom curve, I have 10 points on my top curve, and I'm drawing lines between them. So we now have something interesting going on, because I still have 10 lines coming out. I still have 10 lines on my output. When this was 10, 10, 10 points, 10 points on each curve, I have 10 lines coming out. That makes sense. But when I reduce this, you would kind of be thinking, okay, well, surely I'll have less lines because there's less points. But I still have 10 lines coming out. And so we have 2 different lengths of lists, and we have 10 lines coming out. So what is happening here? And this is known as longest list mapping. And what Grasshopper does constantly, doesn't matter what, whenever you plug something in, the longest list mapping applies. It's Grasshopper's default behavior. And so what is happening is that it defaults, when it maps these 2 lists to each other, it defaults to the longest. So, and this is happening in the background, and it's kind of invisible to us. So, which is why I think it's a concept that people don't understand too well. So what's actually happening is that if we look at our lines on the output, we go 0 to 0, makes sense, 0 to 1 to 1, 2 to 2, 3 to 3, 4 to 4, 5 to 5, 4 to 4. And when I get to my 5th one, we're basically drawing lines constantly to the last item, to number 4. So we have 5, 4, 6, 4, 7, 4, 8, 4, 9, 4, 10, 4. Which is the 5th point, but it's the 4th item index. Because item indexes always start from 0. So what is happening here is longest list mapping. So what is happening is this item 4 here, which is my last point, is getting repeated invisibly in the background enough times so our shortest list matches the length of the longest list. And I'm going to show you this behavior with the component. There is a longest list component, and you have to remember that this is constantly. You don't have to use this component. This is Grasshopper's default behavior, so it's constantly happening. And what I'm going to do is I'm going to just replace all my wires so they're coming through my longest list. And so what's happening now is when we put these 2 lists into our longest list function or a control, it's basically going to show us what is naturally happening in the background. And so I have my 2 lists now, and if I put them and they're both 10 items long, and if I put them next to each other, what I can see in my my bottom list is that number 4 item that we had is now being repeated 5 more times. So the length of the shortest list matches the length of the longest list. This is how Grasshopper maps things against each other by default. We are just highlighting that behavior using this longest list mapping. We can we can change that behavior with this longest list component, because we can right click and we could say repeat the first item. It's quite arbitrary that the last one would get repeated, but that's how Grasshopper works by standard. But we could repeat the first item. So now our first item is repeated 5 times, and then we have our the last points. We could interpolate the problem, where the problem gets divided up equally throughout the list. So I get 3 of my first point, 1 of my second point, 3 of my middle point, 1 of my 7th point, and so on. It spreads out the problem of these 2 lists being different lengths. This is obviously parametrically controlled. So if I change the length of my, my shortest list, if I change the length of my first list as well, this is, this is going to affect everything. I just want to show you how this behavior works. If we have two lists the same length again, this is, this is not going to do anything. The longest list mapping still applies, just as a general rule. We can also, so if I leave this on 5, let's leave it on 4 because it does it nice and symmetrically. We can also wrap the lists around, and we can also like reverse the list as well. So we can change that default behavior that's happening in Grasshopper. So I'm going to repeat first, and I'm going to go back to 10 and 10 because I want to show you something else. So we have two lists exactly the same length, and what I'm going to do now is I'm going to add some structure to our data tree. So what I'm going to do is I'm going to come to my longest list, and I'm going to graft. Actually, I should graft from my divide curve, so then we see that the wire is grafted. This is best practice working, just so we always see the wire. So what I'm going to do is I'm going to graft the initial divide curve on the output. And we're going to look at these before we get to longest list, we're going to look at these two lists against each other. So now I have one list with a branch structure, and I have one list that is flat. That is, just my points. And I have all of these lines, happening across my Rhino window. So this is, again, longest list mapping happening again, because every single one of my branches is acting as a list, and it's in its own right. So now and my list of 10 points is being mapped to every single one of these points individually. So which is the, I keep saying 10 points, actually it's 11 points. Because items always start from 0. I keep saying 10 points, so apologies for that if that was confusing. We actually have 11 points. So of all my 11 points, and in my flat list, and on my single point in all my individual lists, which list is the longest? If these are individual lists separated by branches in their own right, then these are the shortest list. So these points are going to get repeated 10 more times. So there's 11 items in each list. So we can map them properly to our flat list of points. So this is and we can see this behavior with our longest list mapping component. I can see that I have my first point that's repeated so until it's 11 items long. I can see that for my second point, my third point, my fourth point, and so on. And in my my output, my repeat, this should be on repeat last, not repeat first, but it doesn't make a difference in this sense. Our points now are following the same branch structure, and these are now the list is being repeated 10 times or 11 times in order to match how many points we have in this list. And the effect of this is that we get a line being drawn from every point to every point, because of how longest list mapping works. And I can remove longest list mapping. This is just to completely show you that this is how Grasshopper operates. This is its default behavior. When we map two lists like this together, the shortest list is going to get repeated till it is the same length as the longest list. This is longest list mapping, and it is probably by far the one thing that people don't understand that is going to absolutely destroy your Grasshopper scripts and crash Rhino. Because if you think that we had, when we map 10 and 10 to each other, 11 and 11 to each other, we have 11 lines. That makes sense. But when we graft this, when we have a branch structure coming into being mapped against a flat structure, we are going to get however many items that we have in here multiplied by however many items in here. So 11 and 11 lines is now 121 lines. So it's not just like double, it's an order of magnitude more computation required. This is crazy simple. This is just some lines being drawn, so it doesn't make any difference. But if you can imagine this is happening with Boolean, like very complex Booleans, and you've got, if you somehow don't get your branch structures and you don't understand how this list mapping is working, and you somehow, you think you're Booleaning one thing out of one thing, but actually you're Booleaning one thing out of 10,000 things, or even worse, 10,000 things out of 10,000 things. So it can get very, very heavy, very, very quickly for your computer. And because in your mind, you're not doing anything too different, but because of the branch structure and how these are now mapping to each other with longest list mapping, this can, there's exponentially, order of magnitude more computation required. So to finish this off very, very quickly, I'll just show you down here, we have some other. Longest list mapping is by default, and it is by default repeating the last item. So let me just unpreview this. I just have the same again down here. This is longest list mapping. We have two different lists, and this is one repeat last. I already went through, we could repeat the first, we could interpolate the problem, we could wrap, flip, whatever. We can change the behavior of the longest list mapping, but longest list mapping plus with the setting of repeating the last is what Grasshopper will do by standard. But we also, in this longest list mapping component, we also have two others. We have our shortest list mapping as well. So if we want to change that behavior, and instead of being longest list mapping, we can have shortest list mapping. So when we have two lists, two different lengths, instead of repeating the shortest list item so it matches the longest list, we'll go the other way. We'll actually reduce the length of the longest list to match the shortest list. So I have 5 points along the bottom here. I could keep reducing the length of this list, and it also at the same time reduces the length of my other list. It maps them together with the shortest list. And again, we can trim the end, we can trim the start, we can interpolate the problem. This is another way of changing that behavior. And we also have cross-reference. So cross-reference is essentially what I showed you before. This is we cross-reference our data, our two lists against each other, and we create a list of values that is the maximum. So it's basically grafted against each other. So every single point has a connection to every other point in the other list. And again, there's a few different ways this works. There's holistic, diagonal, there's lower triangle. I'm not going to go into exactly what these mean, but we can change the behavior of how that cross-reference works. Changing, and this is all about adjusting and manipulating how two lists of data are mapped to each other. That is all this is about. And actually even just understanding that you can do that. Most people don't even understand the longest list mapping is happening, let alone that we can change this behavior. So that is the key takeaway. Longest list mapping is happening constantly. Whenever you plug a component, a wire into a component that at least has two inputs, the longest list mapping is going to apply. And just to reiterate again that this is happening constantly. So even, this is even happening with our curve divide. We have a list of items in here, which is one single curve coming into our curve divide. I'm just going to copy and paste this over here so we can, so I can show you. And we have a single number coming into my, it doesn't like when it uses a panel. And we also have a single number in a list coming into my curve divide. List mapping is at play, because we have one curve and we have one set of numbers. That is, this makes sense when we look at this on the screen. If I highlight these, I have my curve and my points. One curve, one number to control how many points are on that curve. What if we put two numbers in, and I'm going to merge these together to be one list? I could just put both. You could hold shift and you could add two numbers in like this, but this is best practice to set it up while we're here, just for another lesson. Why not? best practice to set it up with merge, because with merge we can see the order that these two sliders went into to create this list. When we just plug them both into, we don't straight into the input, we don't know which one's first, so visually we don't see. And so now we see that I just need to set the graph off. So now that we see, I have 10 points running along my curve, and I also have 4 points running along my curve. So this might look a bit weird because they're on top of each other with the same, with the same curve. But what's happening is my planar curve is being repeated twice in the list to match. The planar curve is the shortest list. My list of numbers is the longest list. So planar curve is going to get repeated again in the background inside this divide curve. It never shows us, we can only see it when we use longest list mapping. And the output is that I now have a branch structure. I can see that with my dashed line here. And so I have one branch of data, which is corresponding to the points that are allocated on this first slide, second slider, and then another branch depending on whatever's on this line as well. So longest list mapping is occurring even here. It's constantly in play. We have a list of 5 points, and then we have a list of 8 points based on these sliders. So what would happen? And let's just grab our other curve. These are now we're going to merge these two together, and we're going to put this in. So we are now essentially just recreating what we had before, but we're not copying and pasting our divide curve around. We're merging to create lists. We have our two lines that we can highlight here, and we have a number for each of them that we can define. So my first branch of my data structure at the top is the points on my first curve, and the second branch in my data tree are the points on my second curve, and I can change the length of them. So just by understanding longest list mapping and the branch structures of Grasshopper, we can really get around this problem of having to copy and paste our little scripts around all the time. We can be way more efficient with our components if we just understand that branch structure and how those lists map against each other. So this is longest list mapping. Again, it's something that it gets overlooked quite a lot, but it's constantly at play. So you really, really need to understand it. So play around, write the script yourself. If you have any questions at all, please put them in the comments. I'd be happy to answer. This is one of those concepts that's just so fundamental. You really should try and get your head around it. So this is everything I wanted to go through on the video, slightly longer than I intended, but I hope you found this useful. If you have any questions, please comment below. I'd be happy to answer. And of course, if you're enjoying our content, please follow our channel. We would really appreciate the support. And last note, if you are looking for some extra support with Grasshopper, please reach out. We have memberships. We have one-on-one coaching available, all set out, ready to go when you are. So thanks for watching, guys. If you have any questions at all, please put them in the comments below. I'll be happy to answer. Thanks for watching, guys, and I'll see you next time.